everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion we selected Green's theorem. In detail, we will discuss about definition of Green's theorem, problems based on Green's theorem. If capital R is a closed region in xy plane bounded by a simple closed curve. The simple closed curve, that is, the starting point and the terminating point coincides in a curve. Such a curve is called closed curve. If capital M and capital N continuous functions of x and y having continuous derivatives in capital R, then integral over m dx plus n dy equal to double integral R of dou n by dou x minus dou m by dou y dx dy, where capital C is the positive direction, that is anti-clockwise direction. Now we will concentrate on problems based on Green's theorem. Verify Green's theorem in plane for integral, that is a symbol, it is a small circle. It represents, it is a closed curve. The function is 3x square minus 8y square dx plus 4y minus 6xy dy, where C is the region bounded by y equal to root x and y equal to x square. The solution is by Green's theorem, that is integral over C m dx plus n dy, which is equal to double integral R dou n by dou x minus dou m by dou y dx dy. Now, C is the region bounded by y equal to root x and y equal to x square. So looking at the bounded region condition, we are going to draw the diagram. That is, two curves are given in the question. That is, one is y root x, another one is y equal to x square. So the bounded region in a xy plane, so it's a two dimension. So we have the coordinates, the axis are drawn. This is the origin, the center of the coordinates, that we named it as O. So the coordinates are 0, 0. So it's a origin, x-axis and y-axis. So the first one, the parabola, that is, this curve is y equal to root x. Otherwise, we can write squaring on both sides if we take y square equal to x. Another one, this curve, that is y equal to x square. So it is mentioned here. Now, these two curves meet at a point, that is a of 1, 1. This how we obtained while solving the problem, we can see. So now, this is the Green's theorem formula. The left hand side is integral over C m dx plus n dy, which is equal to double integral r dou n by dou x minus dou m by dou y dx dy. This is our given function. In the function, we are going to do comparison with our Green's theorem formula. That is, the left hand side is m dx plus n dy. So we are comparing with that. So after doing the comparison, the dx before, it's nothing but according to the formula m. So we have taken m equal to 3x square minus 8y square, and n is 4y minus 6xy. Now, so we did the comparison of the Green's theorem formula. We obtained what is m and what is n. Now, we have to solve and we have to get the result, the left value and the right side, the formula after substituting, both should be equal. Then Green's theorem is verified. Now we are going to focus on the right side, that is dou n by dou x minus dou m by dou y. That is dou n by dou x, it's nothing but minus 6y. Dou m by dou y is nothing but minus 16y. Here minus of minus 16y, it's nothing but plus 16y. This both together after substitution, we are getting 10y dx dy. So it is written 10y dy dx. So the animated one, which indicates that first two integrals are there, we are going to focus the first one, the interior integration, which is defined for y in terms of x variable. So we have to do integration with respect to y. The doubt it is there. Now the curves we have to put it inside. One curve is y equal to x square, another curve is y equal to root x. Mostly the curves in terms coming, the limits, if we do the interior one, those curves limits, if we are taking, the problem will be no complications will be there. The outer one, the outermost one, we have to give reference for real numbers. Then the result will be in numbers we will be getting. Now here is a doubt that two curves is there. The two curves are there. We selected y equal to x square, the down part, y equal to root x for upper one. What is the reason? Here the curve it is there, that is here this is the curve, here y equal to root x, so the down one, so we put it here, this curve as lower limit, this parabola curve it is in upper position, this is lower position, the lower limit, upper position, that is upper limit. The common point is 1, 1. We have taken, or that we didn't take. Solving with the help of these two curves, we got it this point, that is 1, 1. Now within 2 minutes we will discuss about it. Now, so the 10 it is there, the 10 we put it front of the integral, that is 0 to 1 of y square by 2. So the lower one is x square, the upper one is root x dx. Now this 10 and 2 both are getting cancelled. We got it 5. Now the limit formula is upper limit minus lower limit. So the upper limit value is root x. In the place of y, we have to substitute. So substituting in the place of y, we are getting root x the whole square. So the root x the whole square, it's nothing but x. This is the limit formula as it is. The negative sign is placed here. The lower limit is x square. So in the place of y, we are substituting. So y already square exists for y. So x square the whole square, it's nothing but x power 4. So we completed upper limit, lower limit. So upper limit minus lower limit, that is the limit, the job is completed. Now we have to so we can see it here. So the interior integration regarding with respect to y, we did the integration and we completed the upper limit. The final result of the interior integration is 5 into integral 0 to 1 of x minus x power 4 dx. So this 5 we have written here as it is. X integral is, we know the integral formula, integral x power n dx, which is equal to x power n plus 1 by n plus 1. That is, here x which has the power 1. So n value is 1. So 1 plus 1 divided by 1 plus 1. So x square by 2. This is the problem minus, just we placed it. X power 4. So n place is 4 is there. So 4 plus 1 divided by 4 plus 1. So we obtained x power 5 by 5. It is placed here. So we completed the outermost integration with respect to x. Our outermost integration is this one or this. After integration is completed, now we will concentrate substitution. So the substitution is upper limit minus lower limit. So the 5 which is just it is written as it is. The upper limit value is 1. So x square by 2. So it is 1 by 2. The problem minus is as it is. Here x is replaced by 1. So 1 by 5. So completely we finished the upper limit. So the upper limit minus lower limit value to be written here. But it is not written. The reason is, in the x place we are going to substitute the lower limit value 0. If we substitute, anyway we are going to get the result 0. That's what it is neglected. So now the 5 is as it is. 1 by 2 minus 1 by 5. So the taking the LCM, we got it 3 by 10. Again the simplification 5 and 10 we are cutting, so we got it 3 by 2. So the Green's theorem formula, we simplified the right hand side and we got the result 3 by 2. Now the before only this point, the two curves, the intersecting the point 1, 1, how we obtained. That is, we are taking this y equal to root x and we did squaring on both sides. So y square equal to x. So squaring on both sides. Again we are doing the squaring on both sides. Y power 4 equal to x square, and so we can see here so y minus y power 4, that is we have taken here y minus y power 4. Yeah, this part is very clear. That is we did squaring on both sides. And the next the curve is y equal to x square. One more curve is there, that is y equal to x square. If you do comparison, so where I am putting the tick, this one and this one. So one side where I ticked it, both are equal. So we are equating the another one, that is y power 4 and y. So we will do the equating. We obtained y minus y power 4, which is equal to 0, in which y is common. So we have taken y as outside. Then 1 minus y cube, which is equal to 0. So the y equal to 0. So the next one is 1 minus y cube equal to 0. So minus y cube equal to minus 1. So y cube equal to 1. Y equal to 1. So when y equal to 1, here we can substitute it here. So if you substitute y equal to 1, we are getting x equal to 1. One more value, y equal to 0, if we substitute x equal to 0. That is, we know it here, x is 0, y is 0. So when y equal to 0, x equal to 0, when y equal to 1, x equal to 1. We can substitute any one of the curves, we will be getting the x values. And the point we want it. So this is the point, here the starting 0, 0. The two curves intersecting point is nothing but from which the picture is very clear to us, the point is 1, 1. That's what in the curve, this intersecting point is pointed as 1, 1. Now, the left hand side of the equation, this already we completed just now and we got the result also 3 by 2. Now we are going to focus on this side, that is left side of the Green's theorem formula, that is integral over c m dx plus n dy, for which this left side carefully we have to deal. That is line integral. It's a closed curve. The closed curve, that is, here we can see it, the starting point origin, and they are moving a point. From A it comes to again the origin. That is, starting and terminating points are coincides. So it is a closed curve. Now this OA plus AO, these two line integrals we are going to evaluate, and we will do the addition. First one, OA. OA, the calculation is this part, y equal to x square. That's what it is mentioned here. Line integral along y equal to x square, the parabola, from O to A. From O to A, this is the first line integral. Now we are at the point A. From A to, we have to move to the origin, that is a starting point. The starting point, that's from where we are moving now, from A to O we are moving. That curve is line integral along y equal to root x from A to O. Now OA plus AO, these two integrals we have to do the calculation, and we have to get compulsory the result what we got it, this right hand side result. Both are equal, then Green's theorem is verified. Now, so this is the actually figure, that is the what is the problem condition for the bounded region. The figure, actually animated one, already we have seen. It's the same figure it's a grouped one, it is kept here. Now from O to A we are going to concentrate, that is, just I'm underlining, from O to A we are moving. So this curve is y equal to x square. That's what it is written. We are going to do the differentiation both the sides. So the differentiation is, y differentiation is dy. X square, the differentiation is 2x dx. From O to A we are concentrating. That's what it is written. Now we know our function. Our function is, that is our given problem function. It's a closed curve. 3x square minus 8y square of dx plus 4y minus 6xy of dy, in which we are going to substitute these values. Yeah, the substitution is here. Now the 3x square as it is, the 3x square as it is, minus 8 as it is. Here y is there. The y, the changes one I'm circling. Y place we are writing x square. So the y is replaced and it is written as x square. This square as it is. Dx is as it is. Therefore, it is written y is replaced by x square minus 6x. Y is replaced by x square. Dy, it is 2x dx. Completely, wherever y, we replaced it by x square, and dy, we replaced it by 2x dx. So now with respect to x, we are going to do the integration, that is O to A. One direction we are making. Then we are doing with respect to x, we are going to do the integration. So the x, here 0, here 1. So 0 to 1, the limits. So now we have to do the integration. Before doing integration, what are the possibilities of simplifications we can focus? That is 0 to 1, 3x square as it is. Here minus 8x power 4 dx, 4x square minus 6x cube 2x dx. Next, this 3x square as it is. These two we are multiplying. 4x square into 2x, 8x cube, and these two we are multiplying. Minus 12x power 4 minus 8x power 4 put together minus 20x power 4. We have to do the integration with respect to x, and the limits are from 0 to 1, that we are focusing our line integral along OA. So this is the result. We have to do the integration with respect to x. We know the integral formula, that is integral x power n dx equal to x power n plus 1 by n plus 1. Very simple integral formula. So the 3 is written as it is. According to the formula, n is there. Our problem 2 is there. So 2 plus 1 by 2 plus 1. So we obtained x cube by 3. The next one is plus 8, as it is written plus 8. X cube. So our n is playing the role 3. So 3 plus 1 by 3 plus 1. X power 4 by 4. The minus and minus as it is. The 20 also without any change it is written. X power 4 is there. N is playing the role 4. So after applying the integral formula, 4 plus 1 by 4 plus 1, it's nothing but x power 5 by 5. So we completed the integration. Now we are ready to substitute the upper limit 1, the lower limit 0 in the place of x. So we substituted. Before that, this 3 getting cancelled. 8 to 4, it has become 2. And this is also we are cancelling. It has become 4. Now in the place of x, we are substituting the upper limit value 1. So here substituting x place we are substituting. We did the integration with respect to x. So here substituting 1 cube, 1 plus 2, 1 power 4, 1. So 2 into 1, 2. This minus 4, 1 power 5, 1. So this 3 minus 4, we got it minus 1. So our particle from O to A, we are now at the point A. This line integral, the value we got it minus 1. Now we are at the point A. From A to O we are going to move. That is next line integral along AO, that we are going to concentrate now. Yes, now from A to O we are going to move. So just I am shading the drawing one. That is from A to O we are moving. The curve is y equal to root x. This differentiation we did, the differentiation is root x. This differentiation, root x can be written as x power 1 by 2, that is 1 by 2 x, 1 by 2 minus 1, it's nothing but 1 by 2 x power minus 1 by 2. We can write 1 by 2. This x power minus 1 by 2, we can bring it down. Then it is root x. That is according to exponential law. X power minus m can be written as 1 by x power m. Now, so root x, the differentiation is dx by 2 root x. So now the function is 3x square minus 8y square dx plus 4y minus 6xy of dy. This function, what are these? The curve y equal to root x, dy equal to x by 2 root x. We are going to substitute. That is, now we are focusing on from A to O. So now in the question, in the function, where the changes are there, I will circle it. This is no change at all, as it is. No change. 8 also it written as it is. Whereas y square, it is changed. That is, our curve is y equal to root x is our curve. So y equal to root x, we will do square on both sides. That is y square equal to x. So y square equal to x. This y square, which is replaced by x, dx no change at all. 4, 4. Y is replaced by root x minus 6, 6. Whereas here x is there, actually xy. Y is replaced by root x, that is x into x power 1 by 2. 1 plus 1 by 2, it's nothing but x power 3 by 2. This dy, it is replaced by what I am circling, dx by 2 root x, that we replaced it. So now wherever y this curve we replaced it. dy place we replaced dx by 2 root x. Now, what are the possibilities of simplifications? We can see it. And one more thing, here the limit, that is in one direction, the function, it is in two direction. It is in xy plane. So with respect to x is there, with respect to y it is there. But with the help of this curve, we made it one direction. That is, we are now from A to O focusing. We are focusing from A to O. So from A to O, here, that is 1 to 0. So this point we have to be very careful. So the integral, the limits value from 1 to 0. The reason is from A to O we are moving. So this is the last step of the previous slide. Now the integral, no change. The first 3x square minus 8x of dx, no change at all. As it is written. Whereas here 4 root x, we are taking this 1 by 2 root x inside. Root x cancelled. 4 by 2 is 2. This minus sign is as it is. 6 by 2 is 3. Here x power 3 by 2 is there. X power 3 by 2, it's nothing but root x into x divided by root x. This both getting cancelled. X we obtained. Now, this simplification, that is one direction we made our problem from the xy plane, and we brought it in one direction, x direction. This 3x square as it is. Here minus 8x, here minus 3x is there. Put together minus 11x plus 2 as it is plus 2. Now we have to do the integration. We know our integral, very simple and basic formula. Integral over x power n dx. It's nothing but x power n plus 1 by n plus 1. So now this 3 is written as it is. Whereas the x square, the integration is square 2, that is n place is 2 is there. So 2 plus 1 by 2 plus 1. So x cube by 3. Here minus is there, here also minus is there. 11 is written as it is. X power 1, that is 1 plus 1 by 1 plus 1. X square by 2 plus 2x, that is dx is x. Now we have to substitute our upper limit value 0 and lower limit value 1 in the place of x. So the 3 terms are there. Every term x is there. So if you substitute in the place of x, the upper limit value is 0. Totally, the result is 0. This is limit formula sign. And coming to the point of lower limit value, that where we are going to substitute in the place of x, 1. Already this 3 cancelled. 1 cube, it's nothing but 1. this minus 11 by 2 as it is. 1 square is 1. So minus 11 by 2 into 1, it's nothing but the same minus 11 by 2. Here x place we are putting 1. So plus 2 into 1 plus 2. Integrated, we substituted upper limit minus lower limit. So the complete work regarding limit substitution also over. So the final one is this minus here, and this one we are taking the LCM. Then 2 minus 11 by 4, that is here we are taking here. 2 minus 11 plus 4 by 2 equal to 5 by 2. Now this is our Green's theorem formula. This is the bounded region. What is the condition which is given in our question? According to that, we have drawn the diagram. Our bounded condition is two parabolas. Y equal to root x is one curve. Y equal to x square, another curve. There, these curves, the point of intersection, using with the help of these two curves, we obtained the intersecting point as 1, 1. And this side, or the right hand side, we calculated, we obtained the value 3 by 2. The next here, the line integral. The line integral, first OA we did, that's what here, line integral along y equal to x square from O to A, that we calculated already, minus 1 we obtained. Next, line integral along y equal to root x from A to O, just now we got it, the result, that is 5 by 2. First one, O to A, the result is minus 1. A to O, the result is 5 by 2. Put together, the result of left hand side is 3 by 2. Right hand side already we derived, the result is 3 by 2. So left hand side, which is equal to right hand side, we verified Green's theorem formula. So the next one more problem we will concentrate on Green's theorem. That is, verify Green's theorem for integral over C. Here the previous problem what we discussed taking as a function, here also the same function we have taken, but the bounded region is different. Then what are the changes are going to come, we will focus in this video lecture. That is, x from 0 to where one equation is given, y from 0 to where equation is given. So with the help of these bounded region, we have to draw the diagram, and the same, the function is there, the limits to be found, and Green's theorem formula, the left, the side of the formula, the value which is equal to the right side of the formula, the value, both should be equal, then Green's theorem is verified. Now the solution is, the Green's theorem formula is closed curve. That is, the starting point and the terminating point should coincide. So m dx plus n dy, the dx before 1, this is our capital M, dy, the before 1, this is our capital N. Now, so capital M equal to 3x square minus y square. this one. Capital N equal to 4y minus 6xy. That is the same function of the previous problem, but the limits are changed. So what are the changes are going to come? The same function if you change the limit. That only we are going to concentrate in this, particularly this problem. So this is the bounded region which is given in the question, that is x equal to 0, y equal to 0 and x plus y which is equal to 1. So now x direction, y direction. So both the origin is O and we need a point, that there is a point at x-axis. So x equal to 0, that we will put it in this equation. We are getting y equal to 1. And y equal to 0, we will put it here. We will be getting x equal to 1. So this is the reason how we obtained these points. With the help of this one, x equal to 0, substituting in the equation, y we obtained, y equal to 0, substituting we obtained x equal to 1. So that we pointed here. In the x-axis, we pointed the point 1, 0, that we named it as A, whereas 0, 1, that it lies on y-axis, that point we named it as B. So if a point lies on x-axis, it is understood that y equal to 0. If a point lies on y-axis, x equal to 0. That is the mathematical laws. And both A and B we joined. Now, so this line, it's nothing but x plus y equal to 1. Now, this is the region, the capital R, it is there. So with the help of our the conditions of bounded regions, we joined, we got right-angled triangle. Now this region, it is there, that is represented as capital R. Now we can see a small arrow marks. The small arrow marks, it starts from O2, it moves to A, from A2 it moves to B, from B2 it comes to the starting point O. It is a closed curve. So we know closed curve, and the Green's theorem also, anti-clockwise direction it moves. That is, in the positive direction it moves. Now this is the Green's theorem formula. This is our capital M and capital N, that we are substituting in the place of our right hand side, dou n by dou x. So the dou n by dou x, here there is no x term at all, we neglect it. Here the x term is there, 1 into minus 6y minus 6y. This minus is their formula, that we will keep it. Now dou m by dou y, that is this to be neglected because there is no y term. This we will focus, that is minus 16y. Here we are substituting, already minus is there out, put together it is plus. So minus 6y plus 16y dx dy. Now this is the figure. The same function is same, that what we are doing the first problem, and right now current our problem is 2, the second problem. If the function is same also, according to the bounded region conditions are different. That's what the geometrical figure what we obtained also, it changed. Here we got it right angled triangle. That is the reason specifically this problem is selected. Now here the limits will differ. This is 10y dy dx. Dx dy it is there. Why specifically we changed into dy dx? The reason is the problem while solving this double integrals, the outermost one, if we keep constant values or real numbers values, the problem solution will become very easy. So regarding the curves or in terms of variables, we will give reference to the interior integration. In that angle, in that point of view, now our y, here it is there, our origin. In that 0, 2, it moves to, touches the line, touches our straight line, x plus y equal to 1, from which we can extract what is our limit value of y. So y equal to, we are getting 1 minus x. So we extracted from the straight line equation what is y. So the interior integration from 0 to 1 minus x, 10y dy dx. So when the interior integration which is defined for y in terms of function x, then we have to do integration with respect to y only. That is the reason here the changes occurred. Outermost one is now, it is xy plane. Already y we completed. The leftover is x. So here 0, 0. Here 1, 0. So x from 0 to 1. Yeah, different bounded region, different geometrical figures. The limits values also changes according to the bounded regions differ. Now, this 10 we kept it here. Y, that is y power is 1. Simple integration. Y square by 2, that is y power 1. 1 plus 1 by 1 plus 1. Y square by 2. Upper limit is 1 minus x. Lower limit is 0. That is, we are going to focus. Before that, if it is 10 and 2, we can cut it. It will become 5. So we can see it here. So the next, so we can see it cutting 5. And y place we are substituting the upper limit. That is 1 minus x. Already square is there. So 1 minus x the whole square minus the lower limit value is 0. Anyway, after substitutions we are going to get 0. We neglect it. So this integral we have to do it with respect to x. The integral to do it in the formula x power n is there. Here our n is 2. So 1 minus x power 2 plus 1 by 2 plus 1 is 3, which is correct. Then how we obtained here the negative sign, that is x. The coefficient is minus 1. 3 into minus 1, it has become minus 3. So the limits are 0 to 1. Now we will substitute the upper limit value 1, lower limit value 0. So this 5 minus 5 by 3 we have taken out. X place we are substituting 1. 1 minus 1 upper limit value is 0. Here the sign is minus and the lower limit value is 0. So the lower limit value is 0. Substituting we are getting 1. So minus minus put together we got it plus 5 by 3. Now, so the left hand side, the formula is integral over c m dx plus n dy, which is equal to integral over OA, that is m dx plus n dy, plus integral over AB m dx plus n dy, plus integral over BO m dx plus n dy. Here we can focusing OA and AB and from here BO. So we can see it. Now along OA we are going to calculate. So when the particle from O to A it moves. From O to A it moves. When it moves in the direction of X direction it moves. So X varies from 0 to 1. When it moves in the X direction, Y equal to 0, dy equal to 0. So we wrote it here. So that is O to A. So it moves in the X direction from 0 to 1. This is our given function. In the given function, we are going to substitute these values. If we substitute totally this, it has become 0. And this is also becoming 0. So the leftover is only 3x square dx and x from 0 to 1. That's what it is written here, 0 to 1 dx. This 3 is written as it is x square dx, that is n place 2 is there, 2 plus 1 by 2 plus 1, so x cube by 3, 0 to 1. So the 3 getting cancelled. So 1 minus 0 equal to 1. So the particle from O to A, we obtained the value is 1. So the next one is from, we are now, this calculation is completed. Now we will move from A to B. So when we are moving from A to B, the equation is x plus y equal to 1, dy equal to, that is here y equal to 1 minus x. So dy equal to minus dx. This we are going to substitute in our given function. Here y varies from 0 to 1. This is our equation. So now we will substitute, our dy will be changed into minus dx and y place we will substitute 1 minus x. So now 0 to 1. So here 3 is written as it is. This x is there. Here y minus 1 the whole square. Here minus 8y square. This dx, it's nothing but minus dy plus 4y. This minus 6, here we can see it, minus 6 is there. Here minus 6 actually to be written. This y is y. And here this x, it is replaced y minus 1. And dy, it's so we can see it here. Dy, it is written as it is dy. So in this particular place, we obtained 6 of y minus 1 y dy. Now put together, we are seeing here 3 of y minus 1 the whole square minus 8y square into minus dy plus 4y plus 6 of y minus 1 y dy. So here 3 is written as it is. Here y minus 1 the whole square, that is y square minus 2y plus 1. Here it is written minus 8y square. This is minus dy. Here 4y. Here this 6 is written as it is. And this y minus 1 into y dy. So the last step which is written again. So 0 to 1, 3y square and minus 6y. Here plus 3 and minus 8y square. This is minus dy and 4y. This put together 6y into y, 6y square minus 6y of dy. This completes the simplifications part. After doing the simplifications, we obtained minus 5y square minus 6y plus 3. That is this put together, we obtained minus 5y square. And this is as it is, and this is also as it is written, and minus dy plus this 6y square, and put together these two minus 2y dy. So finally we obtained 5y square plus 6y minus 3. That is this minus we brought inside. That's what the changes occurred here. Plus 6y square minus 2y dy. So this is the result we obtained just now. So if we simplify, we are getting 0 to 1, 11y square plus 4y minus 3 of dy. And we did the integration, that is regarding y square, we obtained 11y cubed by 3 plus 4y square by 2 minus 3y from 0 to 1. So the upper limit, the value is 1. So 11 by 2 plus 2 minus 3. This is the upper limit value minus the lower limit value. Anyway, it is neglected, so it is not shown here. So we derived the result from A to B is h by 3. So one more, the direction is there. We are at the point B. From B to our starting point O, we are going to move. That is, in the y direction we are moving. So when we are moving to the y direction, that is along BO, when we move to y direction, we know x equal to 0. When x equal to 0, dx equal to 0. So y varies from 1 to 0. Now this is our question. So now we are concentrating from BO. So the BO integral, the direction of y direction, m dx plus n dy, which is equal to integral 1 to from 1 to 0 4y dy. So the 4 which is written as it is, whereas the integral of y, it's nothing but y square by 2. So we have to do from the lower limit is 1, upper limit is 0. So we know the formula, that is upper limit value minus lower limit value. Here this 4 and 2 simplifying, we got it 2. Now in the place of y, the upper limit is 0 if we substitute. So the value is 0. The limit formula negative sign, and 1 if we substitute. Here we are getting already 2 is there. Here 1, that is minus 1. 2 into minus 1, we got the result in the direction from B to O. We obtained the result minus 2. So the line integral over C m dx plus n dy, which is equal to OA direction, that is our x direction, then AB, that is the straight line. It moves in the straight line form, and from B to O, that is our y direction. So we can see it very clear from this figure, that is OA. We obtained the value, and AB from BO. So these are the three integrals we focused and we obtained the result. That is, here we can see it. The first OA, we obtained the result 1. The second direction, AB, we obtained the result 8 by 3. The third one, we obtained the result minus 2. So the taking the LCM, the final result of left hand side, the position is 5 by 3. So now, so the total, actually the Green's theorem formula, we proved it. The left side, the value is 5 by 3. So we can see it very clearly. That is the bounded region, what is given. Using that, this geometrical figure, the right-angled triangle we obtained, and this is our function. So this is our Green's theorem formula. So substituting our left side, the value 5 by 3, the right side, the value is 5 by 3. So Green's theorem is verified. So now we will come to a conclusion about this topic, Green's theorem. That is, this is the Green's theorem formula, and this is the function which is given in our question. This is the bounded region where two curves are there. That is y equal to root x, the first curve. The second one is y equal to x square. So using this curve, we obtained this graphical figure there. Y equal to x square, y equal to root x, two curves, the point of intersection. Using this curve, we discussed in detail, and how we got this intersecting point also step by step in this video lecture, which is explained. So next, one more problem we have taken, that is to verify the Green's theorem formula. This is the formula. The problem one what we discussed, the same function we have taken, but bounded region is assumed. We have taken a different one. Then what are the changes are coming if the bounded regions are changed completely? The limits also will be changing. That we have seen practically and we understood. So this is the figure, geometrical figure. Using this bounded region, we obtained it. So in detail, we discussed about Green's theorem problems. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.